All right, here we're going to sketch graphs of the functions f and g on the same axes and then shade the region between the graphs of f and g from a to b, and then calculate the area of the shaded region. So we have our two functions, f and g. And so what I've done is I've plugged those into the function here, y1 and y2. And so our graph looks like that. And so between 1 and 6, if we kind of blow that up and maybe go a little less, maybe we go only to -5, that gives us a better clue. So what we're going to do is we're going to draw something like this. Our F is on top, is the blue. Our red's on the bottom, it's the second graph. And so what we get then is if we draw that on our own here, we're going to have something that goes like this, and it's going to come down, and it was going back up. And again, not very good drawing, and then the other one, it was more of a gradual going like this. And we're going from 1 to 7. So 1's going to be about there, and 7 is just about there. And so that's the area we're looking for. And again, our top one here, that is our g of x. This was our f of x, okay? So we're going from 1 to 7, and we're within the bounds. This is equal to, and this one was 0.54 comma 8.14, and this is 7.46 comma 35.86. Okay, so that's our 2 points. So that's why we know 7's just under that one and 0.5, so 1 is just over that one. Okay, so now what do we do? Well, now we have to go and find that integral. So now we go back over here and we go back to this. And again, let's take our math 9, and we're going to go from 1 to 7. And let's try taking now our f is the higher one, so we're going to take our alpha 1 x and minus, we probably need to have parentheses here. It's supposed to be alpha 1, there we go, minus alpha 2. And so then we have our dx, and we're not putting a minus there, and that gives us 54. Now we could have done it separate, taken the 1 to 7 of y1 minus 1 to 7 of y2, but remember, we could also put it together like that. So it makes it a little easier because we don't have to do all the antiderivative integrals and stuff like that. So we get 54. So here we get value is equal to 54. And again, all we did was we did 1 to 7 of, and we took f of x minus g of x dx, okay, and plugged it directly like that into our calculator, okay? All right, what about the next one? Well, same thing, different functions. So let's go back and again, I've already put these in, so I'll have to turn these two off so we can just see, only those equations that we want. We'll turn that one on, we'll turn that one on, and now we should have those two. All right, so it looks like we have the black one going down, then we have the pink one going up. So the pink one is the ln x one, which is our g of x, and our f of x is the one that's going down. And so let's go back and draw a picture that sort of looks like that anyway. And so again, so we have something, we had something come up here like that. And here, this one was just below, and it comes down like that. And we're going from 1 to 6, and so we're going to go from here to here. So this is our area that we're looking at. Okay. Now, we needed to make sure we did an intersection look, and that was at 0.34 and negative 0.41. And so we knew 0.34 is here, so 1 is to the right. So when we draw a rough sketch, it has to be to the right of there. All right, so again, this one was our ln of x plus 2x, and this was our 0.55 to the x minus 1.82 to the x, okay, or f of x and g of x. So what are we going to do? Well, we're going to go and take our integral from 1 to 6 of, now our ln of x is g of x, so we're going to do g of x minus f of x dx. And again, we're going to plug it all in one shot into our calculator. Okay, so going back here, second quit. And so now we're going to take, this time we're going to take y2 minus y1. And so we'll do math 9. And we're going to go from 1 to 6 this time. And we're going to take alpha, oh, not 2, where we moved that, clear that. All right, alpha 4 minus alpha trace 3, and then our x. Okay, so this should give us our value. So 97.528. All right, so that's our value from 1 to 6 of taking that integral minus that one to get that area between the two curves, okay? Again, we could have done the integral from 1 to 6 of g of x minus integral from 1 to 6 of f of x. Both of them have dx on them, and got the same thing. But that would have required, one calculation and then subtract and another calculation. And this way, it just makes it a lot easier for our calculator use. All right, let's pause there and we'll come back for more.